Hey, good afternoon, everybody. Here's one of those theorems that uses continuity in it. We talked yesterday about how it's a requirement for a function to be continuous for certain theorems to work. Here's an example of that called the intermediate value theorem. I'm going to read it to you. If f is continuous on the closed interval from a to b, and k is any number between f of a and f of b, then there is at least one number in C in the interval a to b such that f of c equals k. Easy stuff, right? Everybody understand? Well, I don't expect you to understand. The idea here is a lot of calculus theorems, if you read it and just read the words to the theorem, you can forget about understanding it. It's very difficult. So we need to look at the pictures. It really is an easy theorem if we look at the pictures. Here's the idea. We're saying, first of all, the function has to be continuous. Okay? For the rest to apply, the function has to be continuous. So here's an example of a continuous function. And they're saying that we have this number k right here. Here's the k. And it's between f of a and f of b. So what you have is three y values. We're talking about this point, and this point. We have three different y values. And all we're saying is there's a k, a y value, between this y value and this y value on the function. Now, given that, it's saying there must be at least one number, we're going to call it c, at least one number, that would give you k, that when you took f of c, you would get k. And it has to be between a and b. Okay, still a little confused? Well, let's look up here. Let's trace f of a across and trace it down. There's a. Trace f of b across, trace it down, there's b. So really we're just forming an interval on the x-axis based on this interval from the y-axis. And we're saying, and what the theorem is saying is that if we pick a point in between, a y value in between these two over here, and we trace this k across and down, it's got to end up, the x value to it must end up between a and b. Okay, I'm losing my cursor. So here it is. So again, they're using an interval on the y-axis. They're using a continuous function to create an interval on the x-axis. And they're saying if you pick a point in between these two on the y-axis, we're going to call it k, trace it across to the curve, trace it down, this x value will be between the a and b. Notice how that fails if you have a discontinuous function. Here's your f of a, traces down to your a. Here's your f of b, traces across to, we're going to call it this b right here. And here's your k that's between f of a and f of b. Now, the theorem says that if you trace this k across, it's going to hit the function, and then you're going to trace it down, and then the x value is going to be between a and b. But this k never does hit the function because we have a discontinuous function. So this theorem does not apply to discontinuous functions. It does apply to the continuous function you see here. All right, how are we going to use that in an exercise? Here's an example. Show that the function x to the third minus x plus 2 has a 0 in the interval from -2 to 0. So we're going to find that f of a and f of b that the theorem was referring to. I'm going to plug in the -2, and here's your a and b, by the way. This is our a and b. So I'm going to plug in f of a, f of -2, and I'm going to get -4 out of it. I'm going to plug in 0. So f of 0 equals 2. Now notice the function goes from being negative to positive. We're talking on the y-axis now. Now if this function is continuous, which it is, because remember, polynomials are continuous everywhere, and this is a polynomial. And because it goes from being negative to positive, then at some point, if you're tracing it through, it must cross the x-axis. It must go from below the x-axis and work its way to above the x-axis. And because it's continuous and you can't lift your pencil, it's going to have to cross the x-axis at some point in time on its journey. And we call that a zero. So crossing the x-axis, we call that a zero of a function. And it's important in many instances in fields related that use math to find where a function equals zero. And so there's the use of the intermediate value theorem. One more point I want to make. We were trying to verify that a function had a zero, or we had a value where f of the function equals 0. You may get, and you will get, a couple exercises where they say verify that this function, there's a value f of something that'll make it equal 12, or make that function equal 10 or 5. And in that case, what you want to do is you want to find two values below and above, show that it will cross there in between, show that it's continuous, and then you want to set this function equal. Let's say we wanted to find what value of x would make this function equal to 10. Well, I can set this function equal to 10 and solve and show that it does have a value. There's a certain x value I could put in that will make this equal to 10. But you first have to use the intermediate value theorem to verify that it goes above and below 10, and that if it's continuous, it will definitely hit 10. Okay, short one today. Good luck. See you soon.